I've got 3 different screens, and I'm looking at those different screens. So bear with me here. I'm going to try and get through this, hopefully in one take, because I am live right now. So let's go over and look at the screen. All right. This is in Paint. This is just kind of a block diagram. This would be your DCC command station. I'm using a Digitrax DCS100 in this case. That's actually incorrect. I am using a 200, DCS200. It's the same thing. The 100 is 5 amp. The 200 is 8 amp. Other than that, they're exactly the same. I would have my LocoNet, I would have my controllers, everything hooked up to this DCS 100 or 200, just like normal. From there, I am linking over to my decoder. This is my decoder in a box. It's my DCC in a box decoder. I'm actually going to do this 4 different times. This one wire, this one line is actually representing both, because as everybody knows in model trains, you have 2 rails. One's positive, typically, in DC, and the other one's negative. In DCC, they are both alternating current. They're both AC, pulse wave modulated. So, but basically you need 2 wires going across there to get both the positive and the negative, or the both parts of the signal. From there, I'm also going to this switch. This is actually going to be a double pull, so DP. Double throw. Sorry, my handwriting with mouse is not very good. What I could be doing. Just a moment, bear with me here. I've actually got a stylus. So DP, DT, double pull, double throw. That means that there will be actually 6 lugs on the bottom of this. And what that's actually doing, let's go back. On a normal switch, on a double throw switch, think of this like a teeter-totter. And your switch thrower up here is actually on the top of this teeter-totter. When you flip this over, it actually takes this teeter-totter and goes that way. If I would turn that up, you've got the switch with the little line, and you've actually got 2 teeter-totters. And so these 2 would be connected right here, and then these 2 would be not. When you flip this switch, it actually rocks it over, and so then these 2 would be connected, and these 2, and not those. So that's how a double pull, double throw works. Probably most of you know what that is. But what we're going to do is we're going to take the raw power from the DCS 100 or a 200. We're going to pipe that into this double pull, double throw. We're also going to pipe it into the decoder. This decoder may be decoder 1000, maybe 2000. I'm kind of planning to do 4 of these. And have it 1,000, 2,000, 3,000, and 4,000. And then the output of this, what would go to a motor, typically in a locomotive, typically this would be inside of your train, inside of your locomotive. I know that's not a very good train, but that would be inside of there. Instead, I'm pairing this up with that. So this output would go to the wheels on the locomotive, to the motor that turns the wheels on the locomotive. What we're going to do instead is we're going to pipe that to our double pull, double throw switch. And then whichever one you have selected actually goes down to your tracks. What that does for you, let me go back here. I'm going to, let's say that you're running in-track standard and you have your layout with your outer, inner, branch. In my club, we actually run a local. All right. So outer, inner, branch, and then at the back of the module, you have your local. This is your module, the side of your module. And we keep those isolated, just like if we're running DC. If we're running DC, each one of those has its own remotes. And so what we would do typically is keep those isolated and then run just that remote to that track. What I'm doing is, let's say that this is 1000 is the decoder. I would actually take this and this would go to my outer. If this was 2000, I would take 2000 and go to the inner. 3000 would go to my branch, and 4000 would go to my local. If I turn it to use the pre-decoded, let's go back. Let's say that it's the 1000. Let's say that I have this switch flipped so that the power will go from here and up. That means that this is now DC. And you can run a analog engine on it. If I have decoder 2000 going this way, what would happen is it would not use number 2000. Number 2000 would just dead end. And so then this would be DCC. And so I would have one switch per track, one decoder per track, one switch per track, and I could decide which line is digital and which one's analog. The only thing that you can't do is you can't do like crossovers. And if you do crossovers, what you want to do is you want to, if you're doing a crossover, you will want to isolate that crossover. Let me show you what I mean. Let's say that I'm doing a crossover here. What I would want to do is I would want to make a break here and a break here and have another double pull, double throw switch pulling power from here, pulling power from here, and supplying that. With these two breaks, I can pull the locomotives into this block, flip it over, and continue on. So that's pretty normal stuff with model trains. So that's what I'm doing with that decoder buddy. That's what I'm doing with these decoders that would be in this road case. Now you ask, what do you mean by road case? Let me switch over here. This is what I mean by a road case. This is actually pretty standard stuff when you're talking bands use road cases for getting their instruments and equipment from place to place. So like this one right here, this is kind of what I'm thinking, only I want a top deck on this with my programming track on top of here. I want to put in a couple of drawers. You can see like on this one, you can put different drawers in there. This has a mixing board for audio. Again, this is a lot of times these cases are made for bands to go to different gigs. But I like having drawers or little compartments. What I want to do is on one of these drawers, I want to put my DCS 100 or 200. In the top of it, if I go back up and find the one that I was looking at, I mean, something like that would be amazing. Like here, up here, instead of this slanted, have it flat. Put my program track on it. And then in these drawers, have my equipment. That's kind of what I'm looking at. These cases are not cheap. If I scroll up here, you can actually see some of these prices. I mean, just for a standard 16U rack, we're talking $799. And that's bare bones. That's nothing in it. But what I like about it is we have these caps that go on and off. We also have the wheels, the nice handles, the nice latches. That's what I'm really looking for in a case. The other thing that I'm going to look at doing is like in the side of the case, or actually I was thinking in the top. Let's go back one here real quick. The case I was looking at, here, let's look at this one. No, that's not quite what I'm looking for. On this one, you can see, can you see? You can't see this one. Okay. Let me bring this over a little bit so that you can see this area of it. Sorry, it's kind of bleeding over. There we go. So this road case right here, kind of what I'm looking at is the front of that comes off, the top of it comes off. It just kind of looks like a good road case for that. Sorry, I gotta, yeah. With this pen, the mouse doesn't like to work very well. But what I'm actually thinking about, and let me see if I can't find one that has this. Let's say that I did go with something like this one. That drawer would be an awesome drawer to be able to put your programming track on. Up here, be able to put your mast up. Down here, have your DCS 100, all your decoders, and everything that we're talking about. Kind of future-proofing it. The other thing is in the side of the case, or actually in the top of the drawer, or maybe up here on this one, depending upon, and again, look at that price. I mean, that's in British pounds, but $2,700. I'm not spending that much on this. I'm looking at like maybe $100, $150 for this case. I'm going to build it myself. The other thing that I'm going to look at doing is putting in some of these Anderson power pole plugs. I'm looking at this just because, again, we've got those 4 lines when we're talking about this decoder that I'm going to be putting in the box. And I'm going to have 4 drops, 1 for every track. Well, here's track 1, here's track 2, track 3, track 4. All in this one set of plugs that'll mount flush inside the case. So that's kind of what I'm thinking. Let's go and talk about the, and I'm going to do a new, don't save. Let's talk about how I'm going to actually build this case, kind of what my plans are. And with this tablet, it'll be nice because I can actually draw a little bit. So I am thinking of a case that I'm doing that on purpose, so bear with me here. Okay, so this angle here, from here to there, let me put in an arc. That angle, maybe it would be better to do it like this. That arc would be 20, or not 25. We're talking 45 degrees. This one right here, we're talking about 80 degrees. Bear with me. I know it doesn't make sense yet, but we'll get there. Then what we're going to do is we're going to put on a base. Standard joinery applies. We're going to come up just as high as the other side. Come up here. And we're going to mirror that. Again, again, 45. These are both 45s, and that is an 80. All right, now, the next thing that I want to do is I want a shelf, and I'm actually just going to put a dado into these two side panels and put in a shelf, glue and screw, and just make sure that it's solid. Then I am going to build, you can do another rectangle up here, that's fine. I'm going to do a rectangle up there. Then we'll go to lines and we will do this. What that'll do is that'll be the top of the case that latches on. That 80-degree angle on both of those will help center the top. If we go to a side view, let's just do a new one. Don't save. I use paint like this all the time. I will have a case like that. If I do this line, I will want to make it a dotted line because the back will be inset into it. We'll get to that here in a moment. I also want handles. We'll put a couple of handles on it. Then let me go back in here and we're going to do another line, and we're going to do, this will be the front door, just like the top. So again, if I would do a top view now of that, of this right here, just that, if I were to do a top view of that, what you would see is something kind of like this. Nope. I can't see. There we go. Okay. Actually, let me just select that. Select that. V. And then I want to flip vertically. Okay. Something kind of like that is what you would see, because the front is going to have this 80 degree and 80 degree yeah, that's what you would see right there on the top view. Once you got to the back, let's say that we do another top view here, you would see it come back. It would be squared off. And then you would have the back. That's what you would see on the back. So that's kind of what I'm working on. In the meantime, right now, we are also working on a couple of new modules for the DCD&W. Let me show you what the DCD&W is. So, you know what? Alright, if you're here for the DCC in a Box Part 4, you can end it now. Just ignore everything past now. This is long enough. 23 minutes is long enough on that. Everything past now is going to be what is the DCD&W and what are we doing to it. If you are from the Kansas area and you've gone to many train shows, you may have seen the DCD&W. If you have seen it, here's what you probably saw. It's a rectangle with rectangles, and there's a bunch of them, ... And then on the other end, so connected from here to there, you have more rectangles, but then you have another big one. So, how did this come to be? What is it? It is David City in Dalesville, named after a couple of our former members of our train club. How did it come to be? We had in-track standard corners. So, as you guys may know, an in-track standard corner would be, I did not mean to do that. I wanted pencil, 4 foot by 4 foot. And you actually take off those two, so these get cut off. And that's actually something like that gets cut off. And from here to here is 2 foot. From here to here is 2 foot. Same thing here. Same thing here. That's 4. That's 2 foot by 2 foot. Let's back up. So let's just make that trying to think of a fast way of doing this. Looking for about centered to about centered. All right. And I'm going to actually overshoot these a little bit. Pour white. There we go. Then I'm going to do the same thing. About centered. Oh. Let's do it in brown again. About centered. To about centered. Overshoot a little bit. And we're going to pour white on here. I always forget to switch back to black. All right. On here, you're going to have a sweeping corner. We're making this a little bit tight there, but okay, something like that. Nope. I'm just going to select Hi, Sally. Sorry, Kitty is in my face here. You probably see a tail right there. That's not going to work. Excuse me, Sally. I'll just draw these in by hand real quick. Just know that those are sweeping arcs. Excuse me, Kitty. Just know that those are sweeping arcs that look nice. Kitty in my way. Kitty booty in my way. All right. Here we go. So there's N-Track standard, roughly. We, like I said earlier, we run what we call the local. It's the N-Track variation that has a, the Prairie division is what it's called. That's what we run. What we ended up doing was we found, and I can actually do this by selecting that. We're going to copy and paste, and we are going to rotate 180. So let's say that we had another club out here somewhere. We found out, my father actually came up with this, that if you come off of here and you go straight to the other club, come off here and go straight to the other club, and you have to get this distance right here perfect. You have to move it in and out to get that dimension perfect. Once you get that dimension perfect, you can actually junction two clubs together. We built that. It works. It's awesome. Our club dwindled a little bit, and we didn't use the well, you can only use that junction when you have enough clubs around to use it. I'm going to go pencil here and go quick and dirty with this. So you have your end of your module here with, let's sketch this. That's your outer loop. And that only junctions your outer loop. We have our straights coming off of there. We didn't junction very often. We didn't do the X very often. Because you got to find another club that is willing to junction with you. We had to exchange a corner with them to make that work. We just didn't use it very often. This dimension is 2 foot, like 8 inches or something, or maybe, I forget exactly what it was. 28, 29, 30 inches, something like that. I don't know exactly what it is. So what we made was we made the little trapezoid piece that went from whatever dimension that is down to 2 foot. With this, what we did was we brought a line there. We brought a line there. And then we also brought a line to the center and back out, something like that. So then we've got 3 lines. And this, yes, is a reversing loop. So if you want to turn your train around, you could come from the layout. You could come in, go out, and then you can go the other direction. So if you're heading in, front in end, then you back it out, and then you're going the other direction. So it is a reversing loop. And we put in some circuit protection for that. But what we ended up doing was we put a big block out here, and this was a 5 foot by 5 foot block. We didn't really use the middle, but we came and we did a loop. And in the middle of the loop, and this 5 foot by 5 foot block was actually 2 modules that were 2.5 foot modules from here to here. 2 of them that were 5 feet long. Make it manageable so that we can move them around. On this one, we took that line right there and we went into a turntable, and we had a bunch of spurs. And some of these spurs actually went over onto the other table. And I put a little control panel over here, and it worked okay. Then, over time, we liked that. It worked well. It was a lot of fun. A lot of people liked it. We said, hey, we want more fun out of this. So, I'm going to move us up a little bit here. Let's just get a new one. So off of, and I'm just going to kind of draw this at a diagonal because I need as much room as possible. Nope. Z. Shoom. And back. So off of that piece, we decided And we're going, these are 2 by 4 foot, not inch, 4 foot modules here, 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 and here. We actually did 4 of them. The first one we just went straight through. We didn't really have any big ideas for it, big plans for it, but we knew that we needed 3 modules for the next section, so we just rounded up to 4 so that we could nest them. On this next one, the straight, and I'll tell you, on all 4 of these, the straight one goes straight through, so I'm not going to draw it. And what I'm going to do is I'm going to only... These are mirrored images. These 2 lines, that one and that one, are going to be mirrored. So whatever I draw over here, just know that I'm doing the same thing over here. So from here, we went straight through once. We then split off on that module. And the split was actually right here, because you don't want these switches right at the corner. So what we did was we put this switch here, and we had it straight from there. Semantics, I know. So let's draw this a little bit better. We come off like that. On here we go back in to the main line, but we also have 1, 2, 3, 4 spurs. And we actually made a complete yard that then dives back into the main line. And like I said, we did on this one, we did the same thing. It is a exact mirror. So there's a lot of lines in here. And then we went to our 5 by 5. That turns it around. Has the turntable. And that was great. We did that for a long time using the club layout and then just coming off in this direction and doing that. But what we found out that we were doing is we ended up getting down so that we were bringing the 4 club modules just to come off and do this. And that, it was a hassle bringing all of this and 3 people that are just doing loops on this one while one person gets to go through all of this. It wasn't fun. So what we ended up doing was, and I need a new sheet again. Sorry about this. I use up a lot of sheets when I talk like this. So we have that trapezoid piece that has these 2 rails are coming in at 90 degrees to each other. And they dive down here, and they have that center rail also. So it's... Alright. That's that trapezoid piece that we started with. We then went to we built another, you guessed it, 5 by 5. And this is just a big loop. That's all it is a big loop. That is the DCD&W. So if you ever see it in the wild, you'll be able to recognize it. You know the way that it came about was we built this piece and this piece. We liked them so much, we added a yard. We liked it so much, we added another loop and made it its own thing. And we maintained all of the compatibility with N-Track standard. So if we ever wanted to, we could get rid of that piece and we could put in a standard corner that was modified with those straight, and it would still work. Absolutely, it would still work. So, what are we doing now? Sally's coming back around, so if you see her tail, like right there, that's what's going on. What are we doing now? We have, me and a friend of mine actually made a set of modules. They are a pair. They go from the DCD&W track plan, the base track plan on either side. They then converge to be in track. And DCD&W. All right. So we already did that. Works great. Yeah, I've got some kinks to work out. Wiring stuff that I didn't get quite right. So, and actually I'm going to leave that up. So, we're growing more and more DCC in our club, in our group. So what we are doing is right now we are making 2 new modules that conform. So let's go back. Right here, this is in track standard. Then what we're doing is we are going with the, sorry I can't spell, Prairie Division. So that is the track plan for the Prairie Division right here. And then we are adding one that is odd. And what we are doing, again, this is all because we're going digital more and more. And we want passing lanes. We want to be able to have 2 engines come at each other and pass one another. So from here, these are our 2 main lines on the DCD&W. This is our turnaround track that goes through the entire thing. This turnaround track will go to the inner and go back to the turnaround track. Not going to be used much. Our main line here is going to go to our branch and then go back to our main line. We are putting in a switch pretty much right there. That'll go to our local and go back to our main line. So now we have a passing area right here. And you guessed it, this one will go to outer and then back. And we're doing another passing line there. That's what that odd one is. The guy that came up with this idea, genius in my book. He taught me everything I know about soldering and all kinds of stuff. He actually has a set of modules that he built for some corners that he built that have in-track, prairie division, and that odd. And what he actually does with it is prairie goes right on through, branch, inner, not outer, outer goes straight on through, and this oddity ducks in to the outer. So in the end you have local, branch, inner, outer, which is in track plus prairie division. That's what we've got. So if we would split these two right here, and we would move this one to attach to here, and we would move this one to attach to here, what would end up happening is we go from DCD&W to a passing lane, double passing lanes. Double passing lanes would then connect to here. Your local would continue as a passing lane straight on through. It's your again, we call this the local. It's actually the prairie division in in-track standard. But that line would go straight on through, and you could put any in-track standard prairie division module in between here, and it just lengthens the siding. Your branch line is the main line for the DCD&W, and it branches off here, goes straight on through, straight on through. You can put anything in here, it goes straight on through, and then goes back to here. Your inner, which is your inner here, it goes straight on through, straight on through, straight on through, whatever you have here, straight on through, straight on through. Your outer, all right? So this one right here gets split for your passing rail, rejoins, so your passing rail is 2 modules long. You put in any in-track standard plus prairie division in here that you want. Then you have another passing rail that is 2 modules long, and back to DCD&W. That's where we're at. That's what we're working on. We're hoping to have it done by the Harrington show. We talked to the people at the Harrington show. They are working on trying to get us some space to assemble all of this. Right now, as it sits, and I really need to do the math again. We've got the 5 foot by 5, so let's call that just a 5. We have that trapezoid piece, which is a 4 foot. We have the 4 pieces that make up the straight and then the yard. And all of those are 4 footers. And I forgot to tell you, what we ended up doing was, because of the 5 foot by 5 foot, because we were coming in so straight here and then going out to this balloon, that was so tight that we couldn't really get that to work. So we actually put in, there's a 3 foot piece right here that we put in that just kind of turns that out a little bit. So that's the DCD&W as it stands. We do have 2 4 foot modules that are the ones that me and my friend made. That go DCD&W to straight in track. And there, and then go back out. So that's 8 more feet there. Then we have the 2 that do the exact same thing with the passing rail. So that's another 8 feet that we could take. And then we have the 2 that do, so that's another 8 feet that do the passing rail to the in-track plus prairie division back to the passing. So we can do all of that now, and that's without adding in any in-track standard into this dog bone. So what we're talking, 5 and 5 make 10, 14, 18, 22, 26, 33. So that is 33 by 5. Did I do that right? 4, 8, 12, 4, 8, 12. That would be 24, 23. 23 plus 10 is 33. Yeah, so that's 33 by 5. If we add this in, which I don't think we're doing this for Harrington, that would add another 8 feet. So that would actually be, what, 41 by 5 if you add that. But being that we're not doing that, if we do this, we'll be at that 41 by 5. If we did both of those, we would be at 49 by 5. And we could do this one also, which would take us up to, what, 57 by 5. But the cool thing is, because we can split on all 3 of these, we can split them anywhere we want. We can put in-track standard modules in. Any of the in-track standard modules that have prairie division here just wouldn't do anything. Anything that would have prairie division would be able to be used as a passing. But anything that would not have that passing rail would be dead-ended. So you would only have the passing rail on the back side, not on the front, with that one. With this one, you have to have this one to make this one work. These would be coupled together. But then with this regular in-track standard, you get all the passing rails still. But then we can put in 2 4-foot corners. And what that would do... Alright, so we're... Well... Let's see here. I want to... Hey, look, I got more room. All right. What you could do with two corners, two 4-foot corners, you could turn it around right away. Even with those 5-foot boxes, let's say that you would put them like here and here. Doing that math, because from here to here is 4 feet, and from here to here is 2 feet, that's known things. That means from here to here is 2. That means from there to there is 2. So that means you have a 4-foot gap in between here. Because this is 2 5x5s cut in half, that means from center line to here is 2.5 foot and 2.5 foot. Well, that together makes 5, and you only have 4. But the thing is, you got to remember is you're working off center line here, not this edge, which this 4 is working off of this edge. So from here to here is 2 foot, and from here to here is 2 foot. So half that, which is right here, that is 1 foot that you take off. So off that 5, it's actually 3 feet. So this plus this is actually 1.5 and 1.5, which equals 3, which that means that this gap in between here is 1 foot. So that is actually doable. Again, I would add both of these to fold it, or both of these to fold it. Both of those would allow you to fold that dog bone shape. So, all right, it's almost been an hour. I'm gonna wrap this up today. In the future, hopefully I'll have some photos. I do have some photos of the DCD&W. We can go into that a little bit. So I'll start marking these as DCD&W part 1, 2, 3, and so on. For those of you that were here for the DCC in a box part 4, thank you for bearing with me. I hope part 5 is not going to be this elaborate, not this much detail of what I'm doing with the DCD&W. I'll try and separate these out. And if I do another one of these combo ones, what I'll do is I'll tell you guys, hey, if you just want the DCD&W, go to this area of the video. I'll put this into the show notes. If you want just the DCC, go to that timestamp. So, all right, I got to get out of here before my wife gets home. She'll be mad. See ya.